Welcome to True Projects. In this video, we are going to explain about the project titled Task Failure Prediction in Cloud Data Centers using Deep Learning. The initiative aims to improve the efficiency and dependability of cloud data centers, which is a crucial demand. In a time of substantial cloud-based services, task failure prediction is crucial. This project utilizes the power of deep learning models such as random forest, decision tree, KNN, and others, with an emphasis on the superior accuracy of the voting classifier by importing necessary packages and methodically exploring and analyzing job failure data. User input for feature values is analyzed and used for predictive analysis through the FLASK framework. In the end, this project provides a proactive approach to reduce downtime, optimize resource allocation, and guarantee continuous cloud service operation, resulting in benefits for both providers and customers. The project uses deep learning techniques to improve the dependability and effectiveness of cloud data centers. Data processing and exploration come first, then data visualization to acquire insights. Then training and testing sets are created from the dataset. Numerous deep learning and machine learning algorithms are used, including convolutional neural networks (CNN) and long short-term memory (LSTM), as well as more sophisticated techniques like random forest, decision tree, k-nearest neighbor, and support vector machine. To forecast task failures, these systems use sparse data. Their predictions are combined by a voting classifier, increasing accuracy. The project provides predictions for proactive resource management in cloud data centers and includes a user-friendly interface through Flask and SQLite for user authentication. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements. In software requirements, we have Anaconda 3 and Visual Studio Community version. Flow of project. To implement this project, we have designed the following modules. The first module is importing the packages. This initial module involves importing necessary libraries and packages such as NumPy, Pandas, scikit-learn, TensorFlow, Keras, Flask, and others. These packages provide essential tools and functions for data processing, model building, and web application development. Second module is exploring the dataset, task failure data. In this module, the project explores the dataset related to task failures in cloud data centers. Data exploration includes tasks like loading the dataset, checking its structure, examining data types, and understanding the features and target variables. Third module is data processing. Data pre-processing is crucial for ensuring the dataset is suitable for model training. This module involves tasks like handling missing values, encoding categorical variables, and scaling or normalizing numerical features. The goal is to prepare the dataset for effective machine learning. Fourth module is visualization using Seaborn and Matplotlib. Data visualization is essential for gaining insights into the dataset. Seaborn and Matplotlib are used to create graphical representations such as histograms, scatter plots, and heat maps to better understand the data distribution and relationships between variables. Fifth module is splitting the data to train and test. The dataset is divided into two subsets, a training set and a test set. The training set is used to train the machine learning models, while the test set is reserved for evaluating the performance. Sixth module is building the model. This is a pivotal model where various machine learning and deep learning models are constructed for task failure prediction. The different models include random forest, a machine learning ensemble method that uses multiple decision trees to make predictions. It is used in this project to improve prediction accuracy by aggregating the results of individual decision trees and identifying feature importance, aiding in proactive task failure prediction. Decision tree, a tree-like model that makes decisions by recursively splitting data based on feature values. It is used in this project for its interpretable rules, feature selection, and risk assessment capabilities, helping data center operators understand and address potential task failures. KNN, k-nearest neighbor, an instance-based learning algorithm classifies data points based on similarity to nearby data points. Assists in identifying task failures by finding the most similar historical instances in the dataset. Support vector machine (SVM), a powerful classification algorithm that finds an optimal hyperplane to separate data points of different classes. Constructs a model to create a hyperplane for separating data points representing successful and failed tasks, aiding in predicting future task outcomes. Voting classifier, an ensemble model that combines predictions from multiple base models, enhances prediction accuracy by leveraging the strengths of various models, providing robust task failure predictions. Convolutional neural network CNN, a deep learning model for image and spatial data, extracting complex features, analyzes historical data, particularly valuable when data has spatial characteristics, aiding in predicting task failures. CNN plus LSTM and LSTM. Neural network models for sequence modeling captures temporal dependencies in data, crucial for understanding how task failures evolve over time. Bidirectional LSTM by LSTM. LSTM variant processing data in both forward and backward directions, captures complex temporal relationships in data, enhancing understanding of task failure dynamics. Recurrent neural network RNN, a neural network for sequential data modeling, models sequential data to provide insights into task failures as they unfold. CNN with K-fold validation, combines CNN with K-fold cross-validation, ensures robust predictions and avoids overfitting, particularly valuable for spatial data analysis. And the seventh module is training the model. Once the models are built, they are trained using the training data set. Training involves iteratively adjusting model parameters to learn patterns and relationships in the data. And the eighth module is building the model with voting classifier, since it gives better accuracy comparing with other models. A voting classifier ensemble model is constructed which combines predictions from multiple base models, random forest, decision tree, etc. This often improves prediction accuracy compared to individual models. And the ninth module is Flask framework with SQLite for sign up and sign in. A Flask-based web application is developed to provide user interaction. It includes features for user registration, sign-up, and authentication sign-in using SQLite, has a database to store user information securely. And the 10th module is user gives input as feature values. Users input feature values relevant to task prediction. These inputs undergo pre-processing to align with the data format expected by the trained model. And the 11th module is the given input is pre-processed for prediction. The pre-processed user inputs are fed into the trained model, that is voting classifier, to predict the likelihood of task failure. The model returns predictions based on the provided features. And the 12th module is trained model is used for prediction. And the 13th module is final outcome is displayed through front end. The predicted outcomes, which represent the likelihood of task failure, are displayed to the user through the project's front end. This user-friendly interface makes it convenient for data center operators to access and act upon the predictions. Comparison graph. This is the accuracy comparison graph. So here on the x-axis we have the score, and on the y-axis we have the different types of algorithm. And from this graph we can say that voting classifier, decision tree and random forest perform well. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the template folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, home.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to the front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model.sav file. These are model files which contain algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and output all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. So here I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and then paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python app.py. And hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address and port. Copy the local link. This is the local link. I'm copying this link and paste it into any web browser. I usually prefer Google Chrome. Now hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up button. Click on sign up button. It has redirected us to a sign up page. So first we need to register here if we are a new user, but I have already registered, so I will click on sign in. And now I will enter the username and the password and click on submit. So we can see the home page of the project is displayed. So here we need to enter these parameters to check whether the data transformation is successful or unsuccessful. So first we need to enter the aggregate memory utilization. An aggregate memory utilization measures the overall memory usage across multiple servers or nodes. It is crucial for predicting task failures in cloud data centers using deep learning. So here I will enter the value of the memory which we have utilized. And the second one is aggregate network utilization. Aggregate network utilization measures the overall data traffic on a cloud data center's network. It is crucial for predicting task failures using deep learning algorithms and so here I will enter the value of the network which we have utilized. And the next one is aggregate local disk I/O. Aggregate local disk I/O refers to the combined input and output operations on individual disks within a cloud data center, and it is analyzed using deep learning for predicting task failures. So here I will enter the value of the local disk which we have used. And the next one is aggregate remote file system NFS I/O. Aggregate remote file system NFS I/O refers to the collective input and output of operation or network file system used for predicting task failures in cloud data centers via deep learning. So here I will enter the value of the aggregate remote file system which we have used. So I have entered all these parameters and now click on submit. So here we can see we got the outcome. The task or job is not failed and data is transferred through cloud is successful. So the transmission of the data through cloud is successful in this. Now again click on sign out and enter the username and the password and submit. So the home page of the project is displayed. Now again we will enter all these values and check whether the data transformation is successful or not. So here I will enter the value of the memory which we have utilized. And here I will enter the aggregate network utilization, that is the value of the network which we have utilized. And here I will enter the aggregate local disk IO, the value of the local disk which we have utilized. And here I will enter the aggregate remote file system NFS IO which we have utilized. So all these parameters will predict whether the data is transferred through cloud is successful or not. Now click on submit. So here we can see we got the outcome. The task or job is failed and data is transferred through cloud is unsuccessful. So here data transferred through cloud is unsuccessful. So we are having two conditions, successful and unsuccessful. So we checked both the conditions. So now click on sign out. And the conclusion of the project is the voting classifier, decision tree and random forest stood out as the best performers in our project and displayed remarkable prediction accuracy. We have successfully improved job failure prediction in cloud data centers through in-depth data analysis and the application of these ensemble and tree-based techniques. These models give data center managers insightful information that enables proactive resource management and reduces downtime. The project's user-friendly interface guarantees smooth delivery of input and predictions. The voting classifier, decision tree and random forest stand out as the most efficient methods in attaining these aims. And this project ultimately provides a robust solution for streamlining resource allocation and enhancing service reliability. Thank you for watching the video.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.